All right, in homework 5.1, we're learning how to do some integration with U substitution. The first thing you have to decide is it a U substitution problem? And so before we get started with this, let's make sure you understand what's going on here. U substitution is how we integrate when it's the reverse of the chain rule. So the chain rule says if you have f of g of x and you do the derivative of that, the derivative of f of g of x, we have to do the chain rule. It's f prime, with g of x still inside of it, times g prime of x. This is a derivative. And so we're able to do this antiderivative if we recognize it. If we have the integral of a derivative function with another function inside of it times the derivative of that inside function, then we can do this integral. So it just goes right back up to f of g of x. So the first thing is, do we have a function with another function inside of it, and we have that multiplying times the derivative of the function? When you look at this first problem, you should notice there is nothing times anything. So this is not a U substitution problem. Neither is this one. This one might be. This could be the inside function right here, and if it's times the derivative of that function, then it would be a U substitution thing. If this is g of x, then we would need g prime of x, which would be 20x to the fourth minus 2. The constant doesn't matter what constant it isn't a problem, but the fact that it's x to the fourth and this one is x squared means that this is not the derivative of the inside function and there's no way to get to it. So this is not a U substitution problem. Now, you should recognize that there is no product rule for integrals, and so you need to multiply it out first. This is the integral of 12x to the 7th minus 6x to the 3rd dx, and now we're just using power rule. I'll let you finish that off yourself. On the other hand, let's look here. Here we've got sine to the 8th of x times cosine of x. Well, the inside function here is sine of x. It's sine of x to the 8th power. I'm going to rewrite this like this. Sine of x to the 8th power times cosine of x. And the derivative of sine is cosine. So this is going to be a U substitution problem. I'm going to say let u equal sine of x, then du, du, the derivative of this function, is cosine of x. And so what we have here is the integral of u to the 8th power times the derivative of that inside function. And this integral we can do using power rule. This is going to be u to the 9th divided by 9 plus c. And then we're going to substitute back at the end. This is 1/9 sine to the 9th of x plus c. And you can see that what would happen is if you did the derivative, the c would go away. You would multiply by 9. It would be sine to the 8th of x times the derivative of the inside function, which is cosine of x. So this is a reverse of a chain rule. Let's look at this next one. This next one also has a clear inside function, and the question is the derivative of this inside function right here? And it is. The derivative of x to the 4th minus 4 is 4x cubed. So this is the integral of square root of u du. That's the same as u to the 1/2. And so you're using power rule, and you're going to substitute back in there. On the back, I like number 8 a lot. Number 8's an important one to be able to recognize. The inside function is clearly this guy, and the derivative of x to the 6th minus 2 is 6x to the 5th. Here's x to the 5th, but it's got a 5 there. That's not going to matter. As long as it has the correct power, it'll be okay. I'm going to rewrite this. I'm going to say let u equal x to the 6th minus 2. du is 6x to the 5th. So, the way I think about this is this is u to the negative 3rd power because it's dividing. So you've got u to the negative 3rd power. Now this is not du. This is 5/6 of du. The easy way to do it is just you divide by what the du is. So this is going to be 5/6, and the x to the fifths cancel out, which is what you need, du. So that's all we're doing. This is u to the -2, divide by the power, -5/12 plus c. Substitute back in the u at the end. This is -5/12 times x to the 6th minus 2 squared plus c. So that's kind of how u substitution works. The answers are always at the bottom, but I hope you see how even if you don't have the exact right constant, it's okay. It's just 5/6 of what we needed.